Assalamualaikum. Today we continue the previous lecture. We will analyze example 12.7. This is example 12.7. Where the I for each element is different. So we start with the first stage. We will calculate the stiffness factor. Stiffness factor K. This stiffness factor will be used to calculate the distribution factor, since we will analyze this frame by using the moment distribution method. So we have three members. We have KAB, we have KBC, and we have KCD. Okay, for KAB, we will use 4EI over L. For E is constant, I is 1000 exponent 6 divided by L is 5 meter. KBC, we use 4EI. Both end is fixed, it is internal member, so we use 4EI. I is 750 exponent 6 divided by 6 meter length. And for member CD, since D is pin, so we use the formula for far and pin, it is 3E. I is 1250 E exponent 6 divided by the length is 7.5. Okay, so for KAB is 4 times 1000 divided by 5, so we get 800 E6. For KBC, it is 4 times 750 divided by 6, it is 500 E6. And KCD is 3 times 1250 divided by 7.5, it is 500 E6. And then we will calculate the distribution factor. Distribution factor DF. So DF for AB is equal to 0, since it is fixed support. And we have distribution factor DFBA, and this is equal to KAB divided by KAB plus KBC, and this is equal to 800 E6 divided by 800 plus 500 E6, and this is equal to 0.615. Distribution factor for BC is equal to 1 minus the FBC, and this is equal to 0.385. Okay, for the distribution factor for member CB, the FCB is equal to 500 divided by 500 plus 500 is 6, and this is equal to 0.5. So the FCD is equal to 1 minus the FCB, so this is equal to 0.5 as well. And the distribution factor for DC is equal to 1, since this is KCD divided by KCD. Okay, this is stage number 1. And then we go to stage number 2. Stage number 2 is Nance-Wave frame analysis. Okay, for step A, we will calculate FEM due to external loading. So we have member BC. It is subjected to 8 kilonewton. BC, we assume that both end is fixed. So the moment based on this W is acting like this, because this is the behavior after the beam bend. So this is WL squared over 12, and this is also WL squared over 12, and the length is 6 meter. So based on this, FEM BC is equal to negative 8 times 6 square divided by 12. This is equal to negative 24 kilonewton meter, and FEM CB is equal to positive 24 kilonewton meter. Okay, for B, to B, it is calculation of M naught. So I will not show how we get the M naught, since I have shown to you in class. So this is the value from table number 1. We have member AB, BA, BC, CB, CD and DC. And this is the M naught value: 9.58, 19.34, negative 19.34, 15, negative 15, and 0. Okay, this is the value from distribution table. This is the end moment value. Okay, then we go to the next step. We want to calculate the R value. We will refer to the diagram in figure 2. This is the diagram. Okay, this is 8 kilonewton. Okay, it is R here, subjected in this direction. This is the reaction due to an imaginary support, pin support, that is located at C. So since A is fixed, this is B, this is C, this is D. So A is fixed, so we will have 3 unknown reaction at fixed support. We have VA, we have HA, and MA. And at D, since D is pin support, so we should have VD and HD. Okay, this is actually diagram for figure 4. Figure 2. Nance-Wave frame. Okay, from this we will produce this equation. Fx is equal to 0, since we have to determine the r value, so the total fx is equal to 0. We'll produce the equation with r inside. So we have HA minus HD minus R is equal to 0. Actually, the HA and HD we can put in any direction that we like. So let's say if I put the direction of HA and HD based on this diagram shown, so I will write the equation based on that. Okay, so from here we will get R is equal to HA minus HD. So how to analyze HA and HD is from the HA and HD, we will determine this value from the column analysis. Right, so we will analyze column AB. So we analyze column AB. So this is the column. We take out only column AB. So in column AB we have moment MAB. We have HA. We have moment, the value is 9.58, and we have MBA also positive 19.34. We have 5 meter column. So this is A and B. Okay, by taking the moment at B is equal to 0, so we will get 19.34 plus 9.58 minus 5HA is equal to 0, so we get HA is equal to 19.34 plus 9.58 divided by 5, so we get 5.874. 19.34 plus 9.58 divided by 5, 5.784. 5.784 kilonewton. And then we will do the same for column BC. So not column BC, it is column CD. Column CD, this is the column. Okay, this is HD. MCD is negative, so we put negative 15 here. Right, the length is 7.5 meter. Okay, this is C and this is D. Okay, so by taking moment at C is equal to 0, it is negative 15 plus 7.5 HD is equal to 0, so HD is equal to 2 kilonewton. So this value HA is equal to 5.784, HD is equal to 2. We substitute into